Welcome all. Welcome to video lectures of Kulkarni's Academy of Mechanical Engineering. It's after a long time I have come up with one question, and this question was asked by many students to me. So I thought of explaining it through this video. This is one of the good questions, and this is on basic thermodynamics. The question is something like this. Now, very good question. There is a smooth vertical tube. This is the vertical tube, but of different cross sections. See, the tube of different cross sections, and this tube with different cross sections is equipped with two pistons with a thin rod. The total mass of these two pistons and this rod, the total mass of this piston assembly, means two pistons plus this rod, is given as 5 kilogram. I repeat, the mass of this piston assembly and this rod is given as 5 kilogram. Now he says the atmospheric pressure, it is open at both the ends, yes, and here it is exposed to atmospheric air, here it is exposed to atmospheric air. Now this contains 0.001 kilomole. I repeat, 0.0001 kilomole of air. Now, this air is heated. Now, when the air is heated, this assembly moves by 20 centimeter. This assembly moves by 20 centimeter. The question is, how much is the work done? Second part, what is the rising temperature so as to achieve 20 centimeter movement of this assembly? And the third one, represent the process on PV diagram. This is a good question. I repeat the question. The mass of the piston assembly, both the pistons plus rod put together, is 5 kilogram, and the difference in area is given, areas. So the top piston, bottom piston, they are of different sizes. The difference in area is 10 centimeter square, that is also given. Now, this is a good question. Let's try to see this, how we achieve. We are heating this. One common observation is, when I heat this, actually, let's try to identify the process. You know, my dear students, my air, and this is absolutely in equilibrium, my air is under the influence of atmospheric air, weight of the piston, here again atmospheric air, this piston and the rod. So when you are heating, neither the mass of this piston, these two pistons, nor this rod, or the atmospheric pressure is changing. Means if you see the normal force, that is the pressure of the gas, if the pressure of the gas is P, if you see the pressure of the gas, you just observe, it depends on this atmospheric pressure, its weight, and therefore these are not changing. So therefore it is basically a constant pressure process. The normal force, you see, it is under the influence of atmospheric pressure and weight. Neither the weight nor this atmospheric pressure is changing. So therefore it is a constant pressure process. And air can be treated as an ideal gas. Let me apply ideal gas equation, which is PV is equal to mRT. The pressure of the working fluid is constant. It is a closed system, so mass is constant. R is a gas constant. The volume is directly proportional to temperature. When you are heating, the temperature is increasing. So obviously the volume should also increase. So it is an expansion. Now, if you observe, if the assembly moves down, more volume fluid is forced to less volume. जब ये नीचे आ रहा है तो more volume is forced to less volume, means volume is decreasing, so it is not possible. So this assembly should move up, so that when it is moving up, the lesser volume is moving towards more volume. Therefore, when it moves up, it is an expansion. So after some time, the situation is something like this. So let's understand clearly. Okay, now this is initial. Okay, after some time, originally it was here, after some time it will move up. Let the distance moved be x, and clearly that x is given as 20 centimeter, this x, and thereby this will also move. Right. Okay. Now it has moved by x. Very good. Very simple, my dear students. The change in volume is equal to change in area into this is moving by x, this is moving by x. So it is moving by same x because it is an integral one assembly. So it moves by x, so it moves by x. So the change in volume is change in area into distance moved, that is x. So I will write this as change in volume as A2 minus A1 is delta A into x. Okay, no problem at all. This is my equation. Chalo, अब आगे बढ़ते हैं. Now let's move forward. Okay. Right. Let's try to understand things very, very clearly. This is a very good question. Now, let's try to draw the free body diagram for the top one. Let us take the top piston as 1, the bottom one as 2. Let me try to draw the free body diagram for the top one. Okay, above there is atmospheric air. So this atmospheric air will push it down. Upper atmospheric air, it will try to push it down. So atmospheric pressure is P0. As it is 1, let the area be A1. Okay. This complete assembly, the lower piston, will try to push it down. Means in this rod, the tension is in the downward direction. Okay. Very good. So this will try to pull it down. Okay. Now, there is air. Let the pressure of air be P. So you may be wondering, sir, pressure varies with depth na. Generally for gases, the gravitational effect will be very negligible for gases. Thereby, the pressure throughout is assumed to be constant. Let the pressure of this air be P. And this air will push it up. This air will push it up. So therefore, let the pressure of air be P. And the area on which this pressure is acting, let the piston area be A1. Okay. And the mass of this piston, let it be M1. Please understand carefully. Please understand carefully. So let the mass of this be M1, mass of this be M2. And the string is very negligible. So therefore, already have written the tension. So no problem. So let the total mass M1 plus M2, mass of first piston plus mass of second piston, the total is given as 5 kg. So therefore, I'm just writing M1. Okay. Now, this can be written as P0 A1. It is an equilibrium, so sum of the downward is plus T. P0 A1 plus T plus M1G is equal to this down is PA1. Let it be equal to equation number 1. Now what we do is, let us try to draw the free body diagram for the second lower piston. Let's try to draw the free body diagram for the lower one. Dekhte hai. Now observe here. Okay. Now there is air. That air will push it down. So therefore, air pressure is P. Everywhere you know air pressure is P, and it is acting on the small area A2. The mass of this lower one, let it be M2, therefore it is M2G. There is outside atmospheric air and that will push it up, so therefore it is P0 into A2. Very good. And you know this, when you are heating, this gas pressure is pushing it up, so therefore on this piston the string will try to pull it up. So therefore here if you see the free body diagram, agar yahan pe down hai so it is the continuous same one, so it will be up here. So this is the free body diagram for this. Now let's try to see sum of the upward is sum of the downward. T plus P0 A2, okay, both are upward, is equal to M2G plus PA2. Okay, no problem. So T will be equal to P0 into A2, okay. T is equal to, of course it is minus, T is equal to minus this, okay, plus M2G plus PA2. Let this be equation 2. This is giving, okay, from this I can write, okay, from this I can calculate T. Now tell me what is T from this. If you want T, it will be PA1, okay, minus M1G, PA1 minus M1G minus P0 A1. Okay, you know these two are giving me values of T, so let me equate both. If I equate both, we will get some relationship. Now let's try to see what is that relationship. Let's equate both. So we have, this is minus P0 A2, okay, this T plus M2G plus PA2 is equal to, now I'll remove this also so that we'll have a clear understanding, okay, and we have taken this should be equal to P, I'm equating both T's, both are same, PA1 minus M1G minus P0 A1. Excellent. So no issues at all. So now, chalo, what we do is, this P0 I'll take it to this side. P0 into A1 minus A2. I repeat, this P0 comes this side, so P0 into A1 minus A2 plus minus M1G, let it go to this side, so M1 plus M2 into G, very good, is equal to, bring this to this side, so it will be P into A1 minus A2, no problem at all, P into A1 minus A2, okay. So let us write this as P0, A1 minus A2, let it be delta A, plus M1 plus M2 is the total mass. Let us write it as capital MG. The total mass of first piston, second piston, the total mass is given as 5 kilogram is equal to P into delta A. Absolutely. So if you want P, please understand carefully, this P is actually air pressure. So P will be equal to, you divide with delta A, P0 plus mg by A. Delta A, of course. You divide with delta A, so it will be P is equal to P0 divided with delta A, so P0 plus mg by delta A. So now observe here, already the value of a P0 is given. The atmospheric pressure is given as 100 kilopascal. Okay, if this is in kilopascal, this should also be in kilopascal. The mass is given as 5 and G is 9.81. This will be in Newton. This will be in Newton. Divide with 1000. It will be in kilonewton. And area. What is the change in area? It is given as 10, but it is centimeter square. So 10 power minus 4. 10 power minus 4. 10 power minus 4. I repeat. M into G, Newton. Divide with 1000, kilonewton. And meter square, kilonewton per meter square is kilopascal. This also in kilopascal. So you will get the value of P as, that is the gas pressure. If I calculate, I am getting this as 149.05 kilopascal. That is the pressure of air inside which is trapped. Okay, no problem at all. But he is not asking what is the pressure of air. and he is asking what is the work done and what is the change in temperature to achieve a movement of 20 centimeter. I repeat, how much movement is he asking? Kitna distance? 20 centimeter. Okay. Means around 1 inch is 2.5 centimeter. Matlab itna wo around 20 centimeter. Okay. So therefore, observe here. You know that PV is equal to M, or here moles are given. So I will write it as N R bar T. When moles are given, koi baat nahi. But this is a constant pressure. This is a constant pressure process. And mathematically also it is confirmed. Idhar dekhna. P is equal to P naught plus, already you know, mathematical also it is confirmed. P is equal to P naught plus mg by delta A. Dekho, atmospheric pressure is constant, total mass is constant, G is constant, the change in area is constant. So therefore, it is undergoing a constant pressure process. If you are representing, my dear students, on PV diagram, it's very simple. PV diagram. And already we know it is expansion. Why it is expanding? The reason is at a constant pressure when you are heating, the volume is increasing. Volume is increasing. This is the change in volume. This is the change in volume. And already you know this pressure is 149. Already we know, we have calculated this pressure is 149.05 something. Okay, very good. Now let's proceed with the change in or how much temperature change is required to bring that 20 centimeter distance. Very simple. Dekho bete, differentiate this. Pressure is constant, volume is changing, so change in volume. Number of moles is constant, R bar is constant, temperature is changing, dt. And he is asking dt. Already you know the pressure. How much is that pressure? And you should be very cautious with units. N is given in kilomole. The unit of R bar is 8.314 kilojoule per kilomole Kelvin. Okay. And how much is the pressure given? 149.05. Change in volume. What is change in volume? Change in area into that distance mode. What is the change in area? 10 centimeter square. Centimeter means 10 power minus 4. And the length, how much it is moving? 0.2. 20 centimeter is 0.2. So change in volume is change in area into length. This is in meter cube. And you should be very cautious. So kilopascal means kilojoule mein aayega ye. So kilojoule mein aayega. Kilopascal into meter cube is kilojoule. And this should also be in kilojoule. So R bar should be in kilojoule. Yes, tallied. How many moles? 0.001. R bar 8.314 into delta T. Excellent. Excellent. No problem at all. No problem at all. So ek bar let's try to calculate. Okay. 149.05. एक second please. 149.05. This is 10 power minus 3. This is 10 power gone into 0.2 divided by 8.314. So I am getting the change in temperature as whenever it is change in temperature, it doesn't matter whether it is in Kelvin or degree Celsius. So I am getting this as 3.58 degree centigrade or 3.58 Kelvin. Excellent. Now, और क्या पूछा है? Yes, work. For a constant pressure process, the work is given by the gas pressure or air pressure into change in volume. The air pressure is 149.05 into 10 power 3. It is in kilopascal. It is in kilopascal. So I converted into Pascal. Pascal into change in volume. What is change in volume? Change in area into length. What is the change in area? 10 centimeter means 10 power minus 4. And the length is 20 centimeter. That is 0.2. So therefore, you are getting this as 149.05 into 0.2. And you should get this as 29.8 joule. 29.81 joule. This is a wonderful question, my dear students. So we have represented on PV diagram. We have seen how much temperature difference is required to achieve 20 centimeter distance, and moles are also given. This is one of the good questions. So I'll be coming up with some more questions and some more concepts on Kulkarni's Academy. And Kulkarni's Academy of Mechanical Engineering is thinking of something big. I mean, is thinking something big for the benefit of mechanical engineering students in coming near future. Thank you for watching this. Thank you. God bless you.